We'll proceed in pseudo calculus problems. Okay, mind blowing pseudo calculus problems. Okay, so we are proceeding discussion in pseudo calculus problems where we are scheduled to take problem to problem. Anyway, next we have given a kind of assignment to the people that if I have a iron rod, okay, or if I have a rod, and then consider that I have n number of rods and I make it in two parts, okay, I break it anywhere. Consider this is unit length and I break it at any place. If I break it at any place into two parts, the bigger part out of these two, I throw in one direction and a smaller part in another direction. Now, where I can break it from anywhere. If this is half, I can break this side also, I can break this side also. But I have to take the longer one and throw it in one part, shorter one throw in another part. I have taken n unit length rod like this. Now, if I go and see the longer part, or the n longer part, what is the average length of the n longer part? Okay, that we will solve through the. So right now we are proceeding discussion. So we will take today area. How to calculate area of a circle as part of repeated summation or summation. How we can calculate the area of a circle through repeated summation. We repeat and we sum it. What I'm trying to say is that if I divide, I have to calculate area of the circle. And to calculate the area of the circle, I have to divide, this is x-axis, this is x-axis, and this is y-axis. In that fashion, now I can chop the circle into many parts. I can chop circle like this also in many parts, n parts, and calculate the area of one part and then sum it. Okay, I mean calculate the area of all the parts. If I chop the circle in this fashion in n part, then each part I have to calculate the area and sum it. Then if anyone would get the area of a circle. So anyone would get the area of a circle in this fashion. Okay, now the concept here is I can chop like this also. So these are called chopping in the Cartesian coordinate system, where we are chopping along x-axis and we are chopping along y-axis. Okay, we can chop like this also. Up, 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 up. Okay, how we can chop? We can chop in a polar coordinate system. But anyway, we are not taking polar coordinate. Right now, it is Cartesian only. That is, this is x-axis and this is y-axis. This is Cartesian coordinate system. This is x-axis and this is y-axis. Anyway, I can mix polar coordinate system into Cartesian coordinate system. Mix. If I take polar coordinate system separately, that is theta and r, then this axis that was x there, this will behave like a theta. And there as y there, this will behave like a radius. This is theta r plane. Okay, whereas here, this is theta r plane, this is xy plane. Both are orthogonal to each other. But we can mix polar coordinate into the xy plane. This is separate polar coordinate system. This is theta and this is r. This is separate Cartesian coordinate system. This is x and this is y. This is x and this is y. This is theta and this is r. Okay, but here in Cartesian coordinate system, I can mix polar coordinate system also. How I can mix? Because Cartesian coordinate system is function over polar coordinate system. In a way, x equal to r cos theta, y equal to r sin theta. X can be variable, theta can be variable. Like how I can mix is, if this is, consider this is x-axis and y-axis. This is x-axis and y-axis, or this is x-axis and y-axis. This is origin. In that fashion, hope I don't have the third one. Okay, if that is the case, then I can take one radius, one line here, and starts from x-axis and fix one side of this radius to the origin, and then from here now start moving like this. Someone can say a vector is moving, vector which has one side line one side at origin and other side going like this. Someone can say it looks like a position vector, but anyway, this is radius, and radius can go like this. Okay, what is changing here? Both are may change. One thing that is changing here that people can see is the angle. There are two things that is changing here. Okay, one thing that is changing is the angle. This angle is changing. Okay, and another thing that is may change is the radius. Okay, so whatever it is, this is polar coordinate system where angle is one coordinate and radius is another coordinate. But this term are in concept of Cartesian coordinate system. This is actually not a polar coordinate system. Generally people think polar coordinate system means there is angle and there is radius. This angle and radius is because we are talking about hybrid Cartesian coordinate system and polar coordinate system. Typical polar coordinate system will be theta and r. Simple. That is polar coordinate system. Polar coordinate system inside Cartesian coordinate system, if I mix it, if I try to create the hybrid model, it will look like this. There is a radius and radius is moving in angular fashion like this. Whatever, if someone consider angular fashion, it is up to him. But this is how radius is moving. Okay, making angle. Angle is changing. Radius can also change as a function of angle. If radius is like this, then there is a chance that if I keep growing the angle, the radius may shrink. Means radius is varying upon theta. Okay, now I believe this would be obvious question now. What about xy plane into r theta plane? Someone can think now. Why I said that this is r and this is theta? Because we have taken a function as x equal to r cos theta, y equal to r sin theta. If I see these two functions, it works like x square plus y square equal to r square. It looks like a circle. Makes sense? If I say I have a function x equal to r cos theta and y equal to r sin theta, then x square plus y square equal to r square. That is exactly this is exactly a equation of a circle. So where we have radius as r, so this is x and y, this is x and y, x and y. The radius will move like this because it is a circle. Similarly, someone can think in r theta plane. Consider this is r theta plane. This is theta and r. In r theta plane, how x y will be drawn? Provided provided theta provided theta equal to tan inverse y by x. Makes sense? X equal to r cos theta, y equal to r sin theta, y by x equal to tan theta, theta equal to tan inverse y by x, theta equal to tan inverse y by x. Okay, in that fashion, r equal to a square root of x square plus y square. Okay, that is a function for the theta. If I have theta r plane, if I have theta and r plane, theta r plane, then we have theta equal to tan inverse y by x, r equal to square root of x square per y. If I have this function, someone can invent how x y would look in theta r plane. But in xy plane, theta r will look like a circular. Anyway, now, if it looks circular, then we can compute the area of circle by dividing this circle into n number of parts in polar coordinate system. Meaning, if this is x-axis, if this is x-axis, and this is making theta angle, if this is x-axis, if this is making theta angle, then theta is moving like this. Means radius, this is x-axis, and this is radius, then radius is moving like this, making angle theta. Okay, in that fashion, this is one area. This is one area. Okay, now if I move like this, hope, I believe I can show like this only. This is x-axis and radius move like this, and this is the arc. This is one section of the area. I'm talking about circular area. This is one section of the area. If I take this and make like this, then this is the arc of the circle. This is another area. This is another area. Okay, let's take n number of area. So I'm dividing this circle. I'm dividing this circle into n number of area. Okay, so many sections I made. What now if I say area number 1, area number 2, then we have circle area as area number 1 plus area number 2 plus area number 3 plus area number n. If I add all the area, because they are not overlapping to each other. One area is not overlapping another. So I can say the area we are talking about bringing integral calculus through repeated summation. Okay, through multiplication I can bring integral calculus. That is 100% right. Through repeated summation also we can bring integral calculus. Okay, this is another way to solve any problem, and this is what we will do when we were talking about calculating the length of the, if I cut any stick, iron rod or a stick into two parts, cut from anywhere and into two parts and take the bigger one and keep arranging the bigger one, what is the average length of bigger one? We will start with the repeated addition and we will see that how it brings to integral calculus to solve the problem. Okay, here we will now, what is the area of a particular section? Area of a particular section is how much? That is under question now. If this is a, consider this is ith section. This is the first section of the this area, this full area, I divided into polar coordinate system into n part, where this is first part, this is second part, this is ith part. Consider this is ith part, where the angle between it is delta I. Okay, this angle is very small because I have divided into n part. This is delta I, delta I. This is radius r. This may not be radius. This is radius r. This is a radius r. But radius r can also be function of theta. Means if I say this is the radius of the circle, okay, this is the radius of circle. Radius, like I have given an example like r equal to cos theta. R equal to cos theta is equation of a circle only. R equal to cos theta. If someone draws this R equal to cos theta, it will lead to a circle. Okay, this is origin and this is x-axis, this is y-axis. In that fashion, there is a circle like this. This circle is touching the y-axis. Here, the circle is touching the y-axis and this is the circle. Okay, in that fashion, this equation of the circle is r equal to cos theta. How it is r equal to cos theta? This is origin. The radius will span like this. R equal to cos theta. Radius, since from origin radius will start like this. When theta is 0, r equal to cos theta radius is 1. When theta is growing, radius will start shrinking. It is seen now. See, the radius is here. It is full diameter of the circle. But as we go along, radius starts shrinking. At 90 degree, the radius is shrinking from here. Connect any point here. Connect any point here. Radius is shrinking. When angle is 90 degree, radius has come to 0. Okay, when angle grows beyond 90 degree, radius will start growing like this only and radius will become like this. When angle goes beyond 90 degree, radius will start going, but radius will be negative. Negative radius means if I want to make radius negative, r equal to cos theta. If theta is beyond 90 degree, then radius is negative. If I want to make radius positive, if this is the radius it is going on, when theta is more than 90 degree, to make it positive, I'll take other direction of the radius. Now this is positive. So it will start like this and it form a circle, r equal to cos theta. Now in that fashion, if I have taken any section, now I divide the circuit into n part. Okay, this is first part, this is x-axis, this is the first part of the circuit, second part, third part, small part I have divided. Let's take ith part. Let's take ith part. If I take ith part, okay, then we have something like this, a triangular shape, where this is the ith part of the circle. In that fashion, this is the circumference or arc of circle. Mind it, when they may not be same. This radius and this radius may not be the same. But what is the angle? What is the angle here? Till here, this is x-axis. till here the angle is theta. Okay, and this is ith section. Consider this is delta theta I. Means if I take first section, then angle is delta theta 1, delta theta 2, delta theta I is the angle, which is at angle from the x-axis as theta or theta I, whatever it is. Now, what is the area of this? If I know area of this, then I can do summation all over. But anyway, what is the net area of the circle? That is under question mark. What is net area of the circle? That is area 1 plus area 2 plus area 3 plus area 4 plus area 5 plus area 6 plus area n, or summation sign I equal to 1 to n area AI. A is subscript, superscript is on top and subscript on bottom right side. A, capital A, right, bottom, small I equal to 1 to n. This is the area. This is the area of the circle. Okay. Now, what is the area of the ith section? What I said, summation I equal to 1 to n AI. What is AI? Area of the ith section. Now, I have two radius. I have two radius. And this radius as a function of theta, because as theta is growing, radius is changing. This radius as function of theta. If these two radius are function of theta, then I can use our great concept of that is called that is called pseudo calculus. Pseudo calculus means I can think at it is a kind of, since radius is function of theta, this line is, this line is function of theta, this line is function of theta, whatever it is. Now this forms a triangle. If someone sees it, this form a triangle. If this form a triangle, what is area of this triangle? If this is a triangle, then I can think this triangle as a half of, what is the area of a triangle? Area of triangle is half into one side and another side if they are, I'm sorry. What is area of a triangle? Okay, let's take a triangle. What is this area of this triangle? What is the area of the triangle? Area of the triangle is width into height by 2. Area of a triangle is width into height by 2. Because if this is width and this is height, it forms a rectangle. If this is width and this is height, it forms a rectangle. In that sense, this is the half of the triangle. Whatever it is, we will talk about it. What is the area? What is the area of this triangle? Consider what is area of the full circle? That is pi r square. I know area of a circle is pi r square. I'm talking about pseudo calculus. Pseudo calculus means calculus that is in simplest form. If I take a circle and there is a radius, what is the area of the circle? Pi r square. What is the area of the circle? Pi r square. Where the angle is 2 pi. Where the angle is 2 pi. What is the area of circle per unit angle? Per unit angle. Then it will be pi r square by 2 pi, because for 2 pi angle, the area of the circle is pi r square. For 2 pi, it will be pi r square by 2 pi. It will be r square by 2. Okay, since we have calculated per unit angle, then we have missed. I'll rephrase it. Area of circle is A. A is same as A by theta into theta. Okay, where if theta is 2 pi, then A by 2 pi means A by theta means per unit theta, how much is A into theta? Makes sense. Area equal to area by theta into theta. If I say area by theta means per unit theta, how much is the area? Okay, area is pi r square when theta is 2 pi. Per unit theta is pi r square by 2 pi, r square by 2 into theta. Means area of this small triangle is 1 by 2 r square into theta, and theta is delta theta I. Makes sense. This is called pseudo calculus. Means think in simple manner. What is area of one ith triangle? We have divided the circle into n part. I want to say triangle into n part. So net area is summation I equal to 1 to n ai, where ai area is 1 by 2 r square delta theta I. Okay, this is the now how, okay, someone would say, so anyone can contradict it, saying that then we can calculate the perimeter also in that fashion. Perimeter means I have the full perimeter is 2 pi r. Then if I take a small section as perimeter, now I divide the perimeter into n section. This is the arc or perimeter of a circle. I divide it into n section. Okay, this is x-axis, this is x, first section, second section, third section, fourth section, like this, n section. What is the perimeter of any ith section? Then it will be again 2 pi r, that is the full perimeter, divided by 2 pi, that will be r, and then angle theta. For any, from the center, if I draw, a small section, that I have taken so many sections in the perimeter. This section length will be, then it will be r into delta theta I. If this angle, above, this is from center. So if this angle is theta, if this angle is delta theta I, then this will be r into delta theta I. Okay, r into delta theta I. R is varying with the theta. We cannot take this. Why we cannot take this is that actually what we are trying to say is this is r into delta theta. Considering r as constant, then I can estimate this as r delta theta I. R is varying. If r is varying, here r is like this, and after some time r can be this much only, because r is varying. In that fashion, I cannot take this as r theta, because r is function of theta, and in this we have only one r. So r into delta theta will not give the length. There has to be variable. There has to be variable that is, means if I try to take this length, then this length should be in variable that is variable of theta. Theta and r cannot come together in this way. Like if I am taking kind of if someone contradict, then we will proceed. So here for the circumference we took delta x and delta y, and then we said this is delta x square plus delta y square. Please watch our previous video where delta x is function over theta and delta y is function over theta. Okay, similarly, if we are trying to calculate the area, then area has two sides. One side is radius and another side is radius. These two sides, they make the area. If I have one side as r, if I have another side as r, then these two r makes up the area. If both r is, if I say this one as r1, make, okay, I have divided the circle into many parts. For ith part, we have one line and we have another line. This line and this line, they are not same. This is r1 and this is r2. Okay, r1 is function of theta and r2 is function of theta. Okay, in that fashion, I can more or less I can describe the area in terms of r1 and r2. No problem. Okay, what would be the area in terms of r1 and r2? If I talk about area in terms of r1 and r2, then it will be 1 by 2 r1 into r2. The way we said, the what we are talking here, how it will be 1 by 2 r1 by r2. Consider this is one side, consider it makes a triangle. It makes a triangle, and this is one side of the triangle, and this is another side of the triangle. Okay, and there is a arc that is passing like this. Okay, there is an arc that is passing like this. If I take this arc, okay, and this arc is very small, in a way, consider that this, how I can say, this is how it is. Okay, we will take longer discussion on this. Anyway, Now, what I'm trying to say is if I'm trying to find something, like if I'm trying to find area, and then we have two variable in the area and both variable are function of third variable, then we can go ahead with this even though they are not same. Like if I'm trying to calculate area of some shape where we have x axis and we have y axis. Now, if I'm trying to calculate area of a shape where we have x-axis and we have y-axis, or someone can proceed in better way. This is how right now I have. We will proceed on this. There are many things here. Right now, consider the area of the small as per the pseudo calculus. It is 1 by 2 r square delta theta I. Means area of the ith section is 1 by 2 r square delta theta I. Okay, delta theta I is angle upon them. Or someone can say this looks like 1 by 2 r 1 by 2 r square delta theta I. That is 1 by 2 r r delta theta I. 1 by 2 r delta theta I means r is one side. If this is r, then this is r delta theta. If this, consider this is r, and this is r, and this is r2. Radius is moving like this in a circle, and at one time it is r, and then it moves delta theta I, and this is r2. This is r and this is r2. R and r2 have not changed. In that fashion, how much this arc will be? This arc, I can say in a pseudo manner, it will be r into delta theta I. R into delta theta I. So this is one part of the this is one side and this is one side. This side and this side, they are at perpendicular to each other more or less. Then if I break it, then the area of this triangle that is found by this line, this line, and this line will be, it makes a triangle like this. In this triangle, this is the perpendicular and this is perpendicular to each other. This line is r delta theta I and this line is r2. What is the area? I believe this is perfect. What I'm trying to say is, if I divide this circle into n parts, and then this is the ith part. If this is the ith part, this radius and this radius are not same, but they both are function of theta. Okay, if that is the case, then from here, okay, from here, take a from here. I'm sorry. From here, take a kind of take this arc. Consider this arc is a so small. This angle is so small. Arc can behave like a straight line. If this behave like a straight line, this arc will fall here like a. This arc will fall here like a perpendicular angle, and this is r2. Then this arc length is first arc into delta theta I. R1, if this is r1, then r1 delta theta I. R1 delta theta I is one side and one side is r2. Then what is the area? If I take like this, what is the area of this triangle when one side is r2 and one side is r1 delta theta I? Okay, this area is r2 into r1 delta theta I by 2. Makes sense? This is the closest we can talk. Okay, someone can think more on it. This is not that easy. Anyway, now we are talking what is the area of circle if I divide the circle into n parts. Okay, summation I equal to 1 to n ai. The area of the ith part means a1, a2, a3, a4 up to an is the area of the circle. What is the area of the ith part? If I take the area of the ith part, then it is kind of, it has boundary of two radius. If I take the section I section, this is the first area. Up. This is the first area. This is the second area. This is the ith area. If I take this ith area, if I take this as ith area, what is the area of this? Okay, from here, consider this is small. This is radius is decreasing. From here, I draw this is the arc that is passing like this. If I draw a straight line from here, this is arc here. So if arc is passing from here, arc, if I remove this arc as a straight line, this straight line will be like a perpendicular to at this line. This is assumption. This is called pseudo multivariate calculus at the all. This is formed like this. In that fashion, this is radius 2 and this side what we talk, this is radius 1. Okay, if it goes like this, then this arc length what we are talking that is falling on it, this is r1 into delta theta I. So this is r1 delta theta I falling on it as 90 degree. And this is r2. What is the area that is formed by r1 delta theta I and r2? This will form a triangle where this is 90 degree. In that fashion, the area of triangle will be r2 into r1 delta theta I by 2. So the area is 1 by 2 r1 r2 delta theta I. Now it is perfect, where r1 is function of theta and r2 is again function of theta. So in that, if r1 and r2 are not same, r1 and r2 are not same, but they are same if I write they are function of theta. Both are function of theta. I can write 1 by 2 function of theta into function of theta, where theta varies, into delta theta I. Makes sense? Now, what we get here, the area of the ith section is 1 by 2 function over theta into function over theta, delta theta I. This is the area of the ith section. Now I can rewrite it. What we can rewrite here is summation I equal to 1 to n, summation I equal to 1 to n, 1 by 2 function over theta into function over theta. Function over theta is r. Consider it is function over theta is r, or just write like that one. 1 by 2 function over theta into function over theta, delta I. If I break it, it becomes 1 by 2 function over theta, function over theta, function over theta, function over theta, and then delta theta 1 plus 1 by 2 function over theta into function over theta, delta theta 2. This is exact sign of 1 by 2 function over theta whole square d theta, where theta is from 0 to pi. Why I said to pi? Because if when we have taken our circle, then angle is going from 0 to 90 degree, and then where circle we have taken r equal to cos theta. Circle what we have taken is r equal to cos theta, where theta goes from 0 to pi, and then 0 to pi by 2 and pi by 2 to pi. It is not that easy. Anyway, we have drawn a circle that is r equal to cos theta. If I have taken a circle r equal to cos theta, then if this is x-axis and y-axis, then this is the circle. Okay, where the center is at 1 by 2. If this is x-axis and y-axis, circle is like this. That is, circle is r equal to cos theta, where center is 1 by 2 comma 0, and left side of the circle is hitting y-axis, and in this fashion, where center is 1 by 2 comma 0. Now, if that is the case, whatever it is, now I have the, if I divided the circle into n part, into so many parts, the ith part strip wedge, we say, the ith part wedge area is 1 by 2 function over theta whole square delta theta I. Okay, this will, where summation of I equal to 1 to n will give the all area. This will typically transform into 1 by 2 function over theta whole square d theta. Theta is from 0 to pi. Why theta is from 0 to pi? Because if I have taken circle as r equal to cos theta, theta is growing 0 to pi by 2 and then pi by 2 to pi. There only it makes the full circle. 0 to pi, 1 by 2 function over theta whole square d theta. Makes sense? Now in that fashion, it will become function over theta is cos theta. That function over theta, that is the radius, is cos theta. It will become 1 by 2 1 by 2 cos square theta d theta. It will become 1 by 2. I can keep outside. It will become theta by 2 plus sine 2 theta by 4. Cos square theta d theta integration 0 to pi. Okay, this will become cos square theta d theta. It becomes theta by 2 plus sine 2 theta by 4. Okay, 0 to pi, it will become pi by 2 only. Pi by 2 into pi by 2, the area will be pi by 4. Okay, this is something that is very different. Okay, because the area we came to is cos square theta d theta, whatever it is. This is how it is. Now, if person needs more perfection here, it is not very perfect. Anyone was thinking about that what is the area of ith section? Ith section, what is the area? Where once that is for sure now, area is bound. The boundary of the area is one side. It is R1, where R1 is this is x-axis. From x-axis, consider it made angle theta. If it has made angle theta, then R1 is function over theta. Okay, if it is angle theta, then it is cos theta, because R equal to cos theta. It moves delta theta I. Then this radius is R cos theta, means cos theta plus delta theta I, that is this radius. So this radius is cos theta, function over theta. Okay, function over theta, and this radius is function over theta plus delta theta I. Okay, and then this arc it is making, this arc is not perfect. Okay, this is not the exact arc of a circle. Like if I take this, if I take this as center, if I take this as origin, and then I see the radius, then this radius arc is not the exactly. If this is r, if this is r, and I say, and this is the ith section, from here to here, this is the ith section arc. This ith section arc has two boundaries. One boundary is function over theta, and another boundary is function over theta plus delta theta I. These are the two radius. What would be the arc and what would be the area? Someone is free to calculate and then bring it into I equal to 1 to n, and then ai, and then convert it into integral calculus. What we brought is that area is 1 by 2. Area is 1 by 2. One is function over theta into another is function over theta plus delta theta I. Okay, and then delta theta I. Considering delta theta I is very small, it becomes function over theta and function over theta, more or less r square. 1 by 2 r square delta theta I is the area of the A section. If I put it into summation, then it will convert into 1 by 2 r square d theta. Okay, that we can sum for the 0 to pi. If someone has better understanding and reasoning, he can bring in. Anyway, but this kind of explanation is not available in any of the book. That's why this much heat is going on. Anyway, please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number. Please watch our 2 or 3 previous video and see that how we took the circumference of the ith section, and there it converged into a square root of dr by d theta whole square plus r square, square root d theta. So the circumference of the ith section, if I take, because the net circumference of a circle is all this, if I divide circumference into many sections, the ith section circumference came as square root of dr by d theta whole square plus r square, then d theta, or delta theta I. dr by d theta at theta is equal to I whole square plus r square square root delta theta I. It came as that much, that we integrated over, and it came as the square root of dr by d theta whole square plus r square d theta. Okay, that is the case where we could not take the circumference as one as r theta, r theta, or r delta theta I. If I have taken ith section as like this, one side is radius this, another side is radius this, we have to find this arc for the ith section so that we can sum up this ith section arc. I cannot take this radius, that is function over theta, into delta theta I. I cannot take. Why I cannot take? Because if I take like this, then this arc is not the arc we are talking about, but in area we took it because it is boundaried by another arc. This arc and another arc, it has boundary in both fashion. So we took as approximation, whereas in the circumference there is no boundary. We took this r, and if I multiply by theta, then it behave like it should be completely circular. Then only I can multiply with the theta. Okay, someone we will talk again both in the next session. So how it can, this is not easy, but summation sometimes it makes big sense. Anyway, we will see it.